Hello. Can everybody hear me okay? Just give a thumbs up. Okay, awesome. Thank you so much. Great. Welcome everyone to today's session on integrating MongoDB into your existing development workflows at any phase of development. But first, how many of you have been to the MoMA, the Museum of Modern Art here in New York City? Awesome. Okay, that's most of you. For those of you who haven't, I highly recommend paying a visit while you're in town. I'm a huge fan of modern art, and they have a great collection. In our demo today, we're going to work on a MoMA application together. And alongside our appreciation for art here at MongoDB, we understand two things very well about the developer experience. One, AI is raising the bar for how quickly software must adapt to meet market expectations. But software can only evolve as fast as its foundation allows. And two, accelerating a developer's pace of innovation is the key to helping a business unlock its potential and scale to meet those evolving expectations. And that all starts with the database. At MongoDB, we've always put developer experience front and center because a great developer experience is what allows developers to move fast. And tools and integrations are a fundamental component of that developer experience. So today, we're going to explore the tools and integrations that MongoDB offers to streamline the development process, from setting up your local environment all the way to setting up your automated testing in the cloud. And our focus will be on demonstrating how these tools fit seamlessly into your daily workflows, enhancing productivity and automating repetitive tasks, freeing you up to focus on more exciting things like innovation and hard business problems. So let's dive into how MongoDB developer tools can be valuable assets in your developer toolkit. Imagine this scenario. I just joined a new project, and to familiarize myself with the code and the team's processes, I'm working on a new feature. The project consists of a web application to discover and search through artworks collected at the Museum of Modern Art here in New York City, which are collected in a MongoDB database in Atlas. In the current implementation, users of the application are able to see all the artworks available at the museum, and we're also experimenting with searching through them, using both full-text search and also semantic search powered by vector search on Atlas. So let's go through the process of contributing to this application together. I'll start with defining the portion of the developer workflow that we'll look at today. As a developer, I want to start coding as quickly as possible without wasting a lot of time setting up my laptop and my dev environment. So we'll look at how that's really easy to do when you build with MongoDB. Once I'm ready to code, I want my toolchain to integrate nicely with my IDE, so I don't have to jump back and forth between windows and tools. So we'll look at what MongoDB integrations are available within your IDE and how to best take advantage of them. And once my code is ready to go, and as all good developers, I made sure that my code is well tested. I want to make sure that my teammates' pull requests are validated and tested before they get merged, and that it's easy to troubleshoot issues when they occur. So we'll look at what MongoDB has to offer for that. To run this application on my laptop for development, we'll need a local MongoDB cluster. So let's dig into that first. You're probably wondering, well, why do I need a local MongoDB cluster? Well, it actually provides the best sandbox environment. A local cluster provides a safe space for experimentation without impacting live systems in a controlled setting. It also enables rapid iteration and debugging to test and validate local changes with no network latency, which enhances the quality of applications we build and speeds up our own development. All in all, having a fast local setup is key for accelerating the development cycle and improving overall productivity. Okay, what else do we need now? We said our application allows users to search through the museum's collection with full text and also with semantic search. So our local cluster needs to be able to do full text search with Atlas search. And we also need to include Atlas vector search to develop our semantic search use cases. And of course, it's hard to develop and test our application without any test data, so we'll need to set that up too. But how difficult is all of this to set up? It's actually incredibly easy. And this is how this works interactively. All you have to do is type Atlas deployment setup into your terminal, hit enter, and in just a few seconds, you'll have a local Atlas cluster up and running and ready to go. Luckily, there's also a programmatic way, which makes automating this pretty easy. So let's take a closer look at that together, and we'll switch to the demo portion. Great. All right. So to see what our actual local deployment looks like, we could run, apologies. If we wanted to set up our local Atlas deployment using our command line, we could do that. But as I mentioned, we can also do it programmatically. So here you can see, looking at this init script here, the engineer who set this project up has already configured it to create our local Atlas deployment using this Atlas deployment setup command right here. But because it would take a while for us to actually load the testing data that we need for this demo, I went ahead and ran this script this morning to save us all the time together. So we can go ahead and just take a look at that together. But first, we're going to take a note on what this command is doing here programmatically. You can see that we're specifying that we want to spin up a local Atlas cluster. We're saying that we want to be running on MongoDB 8.0. We specify the port, and we also give it instructions to initialize the database that we want. And you can see here that initdb is actually a directory that includes a series of scripts that we want to run when we are creating this local Atlas cluster. So the seeding data is the part that does take the longest, which is why I ran it this morning. So we aren't actually going to run this script now, but what we will do is we'll connect to the local Atlas deployment so that we can see what the data looks like together. I'm just going to run a quick command to make sure our cluster is still up and running locally. And here you can see that we do have our local cluster. It's called devtools.local, and it is currently idle, which means it is stable and ready to connect to. We're going to go ahead and connect to this using MongoDB Compass. How many of you have used Compass before? OK, awesome. Again, that's most of the audience. Compass is actually our most popular developer tool, so I'm not surprised to see that. But I hope that some of the other tools that I'm showing you today are somewhat new or something that you're familiar with, but you learned something new and can go and take this into your own workday. So we're going to go ahead and connect to our local cluster here just by typing Atlas Deployments Connect. You can select the tool of your choice, and I'm going to go ahead and select Compass. And now we're going to launch Compass. Awesome. You can see here that it launched Compass for us and automatically connected us to our localhost deployment. So to get a quick sense of the data that we have here, I'm going to click into the artworks database and then the MoMA embedded collection. And here you can see that we have all the data that we expect to see here in our test cluster locally. Great. OK. Now let's go back to the slides. OK. But in the world of AI, we now have so many other tools available at our disposal for actually exploring our data in our clusters. If you prefer to explore your data using the assistance of an LLM, you can now use the MongoDB MCP server with the client of your choice. And today, as you probably heard in the keynote, we're excited to announce the general availability of the MongoDB MCP server. The MongoDB MCP server gives your agentic developer tools like Copilot in VS Code, Claude, or Windsurf the ability to intelligently automate and optimize data workflows within MongoDB. It's now possible to explore schemas, destruct complex tasks, optimize indexes, and perform Atlas admin tasks, all without any manual effort. So now that we have our environment up and running, we'll write some code together and see what tools are available in your IDE to work more productively with MongoDB, including the MongoDB MCP server. According to the most recent Stack Overflow survey, 82% of the developers take advantage of AI when they write code. And half of the professional developers who filled out the survey expect that over the course of this year, AI will continue to be more integrated into the process of writing code. These numbers make a lot of sense, AI has the potential to drastically improve the developer experience and help developers move faster. And that's why we've integrated MongoDB for VS Code, our first-party VS Code extension currently installed by over 2.2 million developers with Copilot. With this integration, we make accessing MongoDB documentation, getting insights on your collections and schemas, generating queries, and translating them to your favorite programming language extremely easy. Let's open up our artwork search application and see how this all works. We're going to go back to the demo now. Great. All right, I've already configured the MongoDB MCP server to connect to our local database that we just took a look at together for the demo. And our Copilot chat is also already running here in agent mode, which makes it possible for us to call the tools available in our MCP server. So let's go ahead and ask it for an overview of the data in our cluster to take a look at what data exploration looks like with the MCP server. Awesome. We can see it just ran a bunch of tools. And we can see that it correctly identified that MoMA embedded collection that we took a look at together as our main application data. This is a great overview. Let's take a closer look, though, at what that actual collection contains. I'm asking it here for the schema of that collection and also a sample document. We ran the schema collection tool and also a find command to get that sample document. OK, great. Now you can see what the schema looks like. We have most of the fields that you would expect to see in a collection that's talking about artwork. We've got our artist bio. We have the title of the piece. We have the height and the width. Oh, that's interesting. I wonder what the largest piece of artwork is in the collection. Let's see what that looks like. This sample document also mirrors what we would expect for what this database would contain. Great. Oh, typo. OK, great. It's running an aggregation command so that we can find our largest piece of artwork. Oh, wow. This one is about 300 feet or 9,000 centimeters in width. It must fold or something to be able to fit in the MoMA. That's pretty crazy. Cool. So now that we have a good sense of our data, we are actually going to start writing some code together. So let's take a look at this service class that we have pulled up here. We can see that our task is to implement this method here. And what this method is supposed to do is it's supposed to help us get an artwork piece by department and artist. So to help us out with that, let's go back to the Copilot chat. But this time, instead of running in agent mode, we're actually going to switch to ask mode. And this will switch from calling the MCP tools to letting us use our MongoDB Copilot participant, which makes it really easy to write queries. So to do that, we're actually going to type @MongoDB and then /query. And that's going to make it really easy for us to write a query together. I'm going to ask it to write a query that has sample values so that we can test it easily using our VS Code extension. So let's ask it to write a query that will find artwork in the department architecture and design by artist Otto Wagner. OK. I think I wrote this query in a slightly convoluted way because we actually want it to write the query for us. So I'm going to say not find, but I'm going to give it the database name and the collection as well. In artworks DB and collection maybe if we give it OK, great. There's the query that we want to see. So to test this out, the best thing for us to do is actually to go ahead and open it in the playground, which is part of the MongoDB extension in VS Code. So now we can see our query here, and it looks runnable, so we're going to go ahead and click this Run button. Awesome. Here is what it returned. This looks like what we would expect. We see that the artist is Otto Wagner, and we also see that the department is Architecture and Design, as we would have expected. Great. So we know that our query is working and doing what we want it to do. So now what we can do is we can actually export it to the language of our application code. So we're going to go ahead and select it, and then click on this to export it to Java, which is the language of our service class. Just takes a second. Great. And now we can see that this actually generated a standalone Java main method for us. But that isn't what we need for our service class, right? So what we can do is we can copy and paste the parts that we want, and then use Copilot inline to actually modify this and make it match what we would expect our method to return. So I'm going to go ahead and copy the portion of this that we care about. And we don't need the rest of it, so I'm just going to close that file and close this as well, and go back to our actual method that we're trying to implement. So now we can just go ahead and paste that in, and then I'm going to select it and hit Command-I to open our inline Copilot. And this is going to use the MongoDB Copilot participant to actually modify the code and make it what we want it to be. So you can see here that our method expects a cursor to be returned. So I'm going to ask it to change the query to be more readable, for one thing. We all care about code style. And use a filter, which is a slightly better stylistic thing to do here, and return a cursor. Awesome. That looks like it's doing exactly what we want it to do. So we're going to go ahead and accept the changes. And then, again, we care a lot about code style here, so I'm going to go ahead and format it too. Great. And we can save it. And that is that. Awesome. But you might also be thinking, why are we using VS Code? This is a Java application, and Java developers don't always use VS Code. And you're right. I don't like VS Code either. I prefer IntelliJ. And I'm excited to let you know that our IntelliJ plugin for MongoDB is also a great tool that we have at our disposal. So let's go back to the slides for a moment. Great. So you might be happy to learn about the existence of this plugin then. MongoDB for IntelliJ is great, and it was launched a few months ago in public preview. MongoDB for IntelliJ streamlines the process of writing Java applications on MongoDB. With enhanced IntelliSense, type checking based on your collection schema, and intelligent proactive performance insights, such as missing indexes, MongoDB makes writing code more efficient for Java within IntelliJ and prevents performance problems before they reach production. Insights and index recommendations are actually my favorite feature of this plugin. Performance is top of mind for all of us, and our goal is to help you make the right decisions early on in your development process. So let's switch back to the demo and take a look at our IntelliJ plugin. Great. So I already have IntelliJ open here, and you can see that the changes that we just made in VS Code have already been carried over here. So let's go ahead and refresh our plugin here to take a look at whether or not insights are being provided to us, given these changes. I think it's taking a second to reload. OK. Well, let's get oriented quickly in IntelliJ to see what tools are available to us. You'll notice that we're already connected to our localhost cluster here at the top, and this is something that is built in within IntelliJ. And it's actually not something that was developed by MongoDB. You can see that you can take a look at your data the same way that you could anywhere else. And you can see that our MoMA embedded collection is already present here as well. Great. I'm just going to make sure we are actually connected to it. OK, it had disconnected us from our cluster, which is probably why no insights were being shown earlier. You have to make sure you're connected to your cluster so that it can see what indexes are available to your queries. And now that we're connected, you can see that there are actually performance warnings that are being shown here for our query. You can see here that there's a missing index note in addition to this performance warning here. We can see that our query is not using an index, which when you're running locally might not matter that much when your data size is small, but as soon as you take this to production with a much larger data size, if you're running this query frequently, it could be detrimental to your application's performance. So we're going to go ahead and click Create Index. Great. Now we have exactly the code that we would need to run to be able to create that index, all with one click. So now that we have this here, we can feel confident that MongoDB is helping us early in our journey to actually improve our performance as we write our application code. And with everything here, everything's looking good. So we can actually now submit a PR for this code, but we won't do that now because I already did it earlier today, and I wanted to make sure that we could continue quickly through the presentation, because as we all know, that might add a little bit of time. So let's go back to the slides, and we'll take a look at what the next part of our workflow looks like together. Great. So now that we've written some great code, the next step is to submit the PR that I mentioned and a pull request to somebody on the team so that they can take a look at our code so that we can run some extra tests together and check to confirm everything is going to work as we expect in production. So let's see where MongoDB tooling integrates into that process. We'll start with taking a look at what the pull request looks like when it's submitted to GitHub. You see that when the PR was submitted, two workflows were triggered, one for unit and integration tests and one with end-to-end tests. I'm going to walk you through how this is set up and more specifically, how to take advantage of MongoDB tools in a GitHub action. For unit integration tests, everything there happens locally. All the dependencies, including the database, run within the workflow. This is convenient because GitHub makes it very easy to orchestrate, and because running everything locally means shorter feedback loops. So let's go through how that's configured in our unit integration tests YAML file. Service containers are a feature of GitHub Actions to run services needed to test or operate an application in a workflow. For example, in our case, we need to run integration tests that require access to a MongoDB database. And having a local database makes the tests run much faster. The same considerations we discussed earlier for the local development environment all apply here. And this code snippet shows how, within a workflow in GitHub Actions, you can create a service that provides a MongoDB database with Atlas Search and also with Atlas Vector Search, all out of the box. What this means in practice is that the local experience for Atlas is also available in Docker or Docker Compose. So if your entire development workflow is based on Docker, you have the option of using this Docker image directly too. So here's our pull request again. And if we look at the results of our workflow, you'll see that all of it is good on the unit and integration tests front. That's great. But unfortunately, our end-to-end tests failed. So let's dive into that and see if we understand what's going on. From the log here, it seems like our artwork service test .getArtworkByDepartment and artist test is the one that's failing. And that's because it's taking too long. And that's actually the test for the method that we just wrote together. So that's also where we queried by department and artist. It's worth noting that our end-to-end tests run against our staging cluster in Atlas. So there might be something going on with latency there, or maybe with having more data that the test runs against. So let's go and see if we can figure out what's going on here. We're going to go back to the demo for that. And for this, we're actually going to use Data Explorer in the Atlas UI. If you're familiar with Data Explorer, you might notice that something looks a little bit different here. And that's actually because Data Explorer now provides a much more comprehensive data interaction experience. And that will help you develop, but also troubleshoot errors like the one we're seeing here against our staging cluster in Atlas. This new experience is currently available in public preview, and you can go to your Atlas project settings if you want to turn it on. So let's go ahead and recreate our query here so that we can debug what's going on in our failed end-to-end test. And to do that, we're actually going to use our natural language query generation feature here in Data Explorer. All you have to do is click Generate Query, like I just did, and you can type whatever you want to ask your database in natural language. So here, we're just going to recreate it by typing artworks in the Architecture and Design department by artist Otto Wagner. Great. That's exactly what we want for our query, and we're going to go ahead and hit Find so that we can see the results. Oh wow, that is taking a long time. I guess I'm not surprised that the end-to-end test failed for performance reasons. While the query's working, we can actually note that this little light bulb appeared while it was starting to run. Ah, okay. This tells us that our query was executed without an index, which is exactly the same warning that we saw in IntelliJ, except now this is talking about our staging cluster in Atlas. So we must have forgotten to also create our index in this remote cloud environment. So Data Explorer makes it really easy to actually go ahead and create this index together. So we can go ahead and do that, and then our end-to-end tests would succeed. MongoDB always has your back. We detected these issues early on during development, and we suggested improvements to improve performance all the way from the beginning. But even if you miss it in that case, you can still find performance issues and debug them, not just performance issues, but also other issues, using the Atlas UI and other tools available to you. Whether or not it's in Performance Advisor or here in Data Explorer, we always have your back, providing the tools that you need throughout your journey. Let's go back to the slides together. So let's look at our developer workflow one more time together and summarize how MongoDB's tools support you across the entire developer journey. First, we use the Atlas CLI to quickly get set up and configure our development environment while preparing our local development cluster. We also explored our test data using Compass and the MongoDB MCP server in VS Code. These are the essential first steps in the development process. Second, we dove into writing application code together to speak to MongoDB. We prototyped a query with MongoDB's GitHub Copilot participant in VS Code, and we ensured that our query is efficient using the MongoDB for IntelliJ plugin. Third, we validated our query's functionality through the automated testing that we have to ensure our application works as expected in various scenarios, including our remote staging environment. And we saw how MongoDB seamlessly integrates testing workflows with local Atlas environments in Docker. And we used the new enhanced Atlas Data Explorer to analyze our query in our remote environment. We also ensured efficient query performance by utilizing the insights and indexes provided by Atlas. Throughout this whole workflow, we harnessed the power of AI and MongoDB's developer tools to accelerate our productivity and gain deeper insights into our database and queries. With MongoDB, we truly support developers at every stage, from setup and coding to testing and optimization, ensuring a streamlined and productive development experience. I encourage you all to try out all of these tools on your own if you haven't already, and see how they can improve your developer productivity. Our MoMA application is just the tip of the iceberg of what you'll be able to do with our developer tools. Thank you so much for attending the talk today. And now we're going to invite Bupendra up on stage from BNY Mellon, who's going to talk to us and answer a couple questions about the use case that BNY has with MongoDB Atlas. Switch to the next slide for that. Awesome. OK. Thank you so much.
Nice.
Great to have you up here, Bupendra.
Thanks for inviting.
Yeah, of course.
Great demo.
Yeah.
Impressive.
Can everybody hear I'm OK? I just want to make sure the audio's good. OK. Fantastic. Thank you so much. Great. So, Bupendra, can you tell us a little bit about why you chose to use MongoDB Atlas at BNY Mellon?
Absolutely. So, just a quick background of my involvement with the MongoDB. I work as an engineering head for Foundation Framework in BNY. I've been involved with MongoDB when MongoDB was a 10 gen. I know some of you might still recall. We've been using MongoDB for a variety of use cases. Specifically within BNY, we are using this in 3 different use case flavors. The number one, very obvious, we want to maintain the state of a workflow. We want to audit a orchestration, or we want to audit a configuration. We use MongoDB, like no question asked, no controversies there. The second flavor that is widely used is we have a lot of discrete data sets, wide variety of databases, and data is spread across all of the places, and we want to render them on a single screen, single page application. And the one common use case is we try to pull all the data together, denormalize it, make it high read performant in a schema, and then use that collection to render the screen on a UI. That's another prominent use case. The third use case that we use is wherever we have a need of, where there's a complex data architecture need, where the schema is very required a flexible schema. Some examples are we want to store the metadata of a document. We want to store, let's say, alerts, which is like you have alerts and have different types of metadata associated with that. I think for some of those use cases, we are using MongoDB heavily.
Awesome, that's great to hear. Yeah, the flexible schema of MongoDB makes it a really great tool for customers like yourself. Can you tell us a little bit more about your specific, I guess you just told us a little bit about your use cases, so maybe we can skip the second question there.
Sure.
But I'd love to hear more about how MongoDB has helped you accomplish your goals. Maybe you can talk a little bit more about like why the flexible schema is useful for your use cases.
So I think the way I see it is, it's a kind of a peace treaty between a developer and a DBA. Developer wants flexibility. They want to run faster. They don't want any interruptions. They want to work without interrupting, without getting a approval from 10 different people. At the same time, our DBAs want to make sure that things are aligned. We give them a guardrails and so on and so forth. So I think MongoDB kind of strike the right balance between both. So developer can quickly spin up a new app. And I think what you showed is pretty much an example of that. I don't need to go outside. I don't need to define, for some folks who remember how we design a database, you have to sit down with the DBAs, your data modelers, and then your DBAs, run DMLs. All that workload is kind of gone away. You just have to, you understand your requirement, and as a developer, full stack developer, you understand what your requirements are. You know what you want to paint on a screen, what you want to process it. You can quickly design a schema, and it can fail fast. It doesn't need to be picture perfect on day one. You can write something for the day one requirement, and then you can iterate on top of it. Versus if you define a very large scale database heavy application, you have to spend months and months to make sure your data model fits all your requirements and everything, and then you start writing things, and then things will fail, and your feedback loop is like big longer. I think this kind of shorten this in exponential effect. I think that's one of the kind of a key reason why we choose MongoDB for certain type of use cases.
Awesome, yeah, that makes a lot of sense, and I'm sure it resonates with a lot of people here in the audience today. I'd love to hear a little bit more about the lessons that you've learned along the way. I know that you've been using Atlas for a long time now, and like you mentioned, it's really easy to get started with your schema, but I'm sure that as your application has scaled, you've learned a little bit along the way. So could you share a little bit more about that? Yeah,
absolutely. So I think one of the, I would say, pitfall that I would use this word here. When you define a schema, a developer is defining a schema with a limited scope of requirement, and if you do not have enough governance on how you're defining a schema for long-term needs, you may end up in a rabbit hole. I think we have seen that. I think it's very important that, of course, we do not want to snatch the liberty of the developers that they can define their own schemas and work faster, and without compromising on that. We still want to have some level of governance which can kind of do a taxonomy for data schema and kind of understand how does it fix in the larger scheme of things. I think that level of governance I think is required. Again, not looking for building a very complicated Irwin diagram from the beginning and everything, but you can always write like some tooling, say lint score, to say if multiple developers are writing and creating their schemas and collection, your lint process can just scan through that, and I think the data visualization tool that you showed on the Compass is a good example of that. You can just understand, people are they heading the wrong path? That may is a recipe for disaster for future. I think you can gauge that early on in the game in the development, and you can do the fix and corrections in the beginning itself. So it's kind of you have to kind of be very practical without compromising on the liberty to the developers. You're also applying some governance in a proactive manner. So I think that's one of the things that I would say is kind of very important.
Totally. I think you did a really great job underlining the importance of the balance there between taking advantage of the flexibility, but also making sure that you're not making decisions that will hurt you later on down the line with your schema.
Yeah.
That's great. Cool. You also mentioned Compass.
Yes.
I'm curious if you can talk a little bit more about how your team uses Compass today and maybe how our other developer tools have helped you and your team.
Sure. Yeah, so I think Compass is a lifeline. We've been using Compass a lot. Earlier, we used a completely different third-party tool to deal with MongoDB. It was costly, there was separate licensing, there was no enterprise license available for that. And then MongoDB introduced us with Compass, and this is also with the on-prem version, by the way. So we have Compass a lot. I think some of the features that I recall that we use heavily or rely heavily on it is, the query builder, like you can write complex segregation pipeline without understanding the syntax. I think that's definitely a plus. We use this, the query optimization. So a lot of time when developers are writing code, I think we make sure that people go in, check and see how many queries have been executed in a lower environment which are not optimized. So you can take proactive measures to kind of create an indexes and so on and so forth. I think that we use heavily. We're gonna, of course, also now gonna try the IntelliJ plugin that we announced today. Especially very interesting to see the MCP version of it. So we're definitely going to try some of these pieces. But yeah, some of these features are, we also use a lot of data import and export functionality. So if you want to test something quickly, create a CSV file, load the data, and test it out. I think we use that feature a lot. One thing I would though add is, which we've been longing for that feature, I don't know if you have that in your roadmap, which is we always deal with doing ETL of data from multiple sources into MongoDB. How can you make our life easier for the developer that without we spend time in writing those ETL, because there's a separate team who's writing that, but the API developer can quickly sweep through the sources and pull the data into MongoDB for the test purposes. Something which is out of the box. I think the announcement that we heard today about the AMP seems like will be a plugin for that piece, but I think we need to explore more on that. I think that would be a really cool feature, because lot of, like you're still having a developer working on different parts, some focusing on ETL, some UI, some API, how we can make them more independent to say, I don't need to wait for my data team or ETL team to extract the data and load my collection. I can quickly do like a quick and dirty load of data and test my APIs and so on and so forth. So I think those are some of the tools that we think will be very advantageous for all of us in the developer community.
Absolutely, that makes a lot of sense. And I'm glad that you mentioned the new AMP program that we put out, the Application Modernization Platform. I hope that it's what your team needs, but if not, we'll definitely work with you and try to figure out what we can do to help improve your ETL pipelines.
Look forward to it. Yeah.
Awesome. Cool. Well, thank you so much. I'm looking back at our list of questions now that we talked about before. Oh, okay, this is another good one. I'm curious to hear how you think the value proposition of MongoDB has changed over time for you, given how long you've been using Atlas now.
Yeah, so we've been using Atlas for more than 2+ years now, and it definitely was a game changer. I want to give one case study which is very interesting and very fascinating. We, on a given weekend, we converted our entire workload of one of the biggest platform that we have, live platform, from on-prem to cloud, Atlas, literally over the weekend. So that was a story that we had early last year. This year, in like early summer, we found a situation where our client has, of course, outgrown, and we have to scale them faster. We went from 1 cluster to 4 clusters, along with MongoDB 6 to 8. The development effort for that was literally 5 days, and I'm not kidding. I have some of my team members who can attest to that. The development effort for that was like 5 days. And again, the whole migration that includes 6 to 8 upgrade, going from 1 physical clusters to 4 physical clusters in tenancy of client, and some other complex logic that we implemented all over the weekend. I think I see that as, if I compare, a poor analogy would be, if I want to move to a bigger house, I would to ask for movers and packers and everything. All this goes away. I go to Starbucks saying I need a large tall, and I get those things. So we use the MongoDB tiering features a lot. We scale based on our tenancy. We scale from M60s, M80 to M200. In fact, we were for some of the tenant, we already went up to M400 because that was a need. And guess what? We didn't need a code change to get this thing done. And if I compare this from last 6 years back, when we were still using on-prem, I mean, this project, these two projects that I mentioned, this would be easily a 6-month project for us, including testings and provisionings and certification of the DBAs, monitoring tools, all these things combined together. So I think definitely Atlas has, the whole managed service capability has given us a lot of benefit on top of, as compared to what we do on-prem version.
That's fantastic. And I love that analogy of not needing to have the movers and the whole process. That's fantastic that it only took 5 days for your team. I'm really glad to hear that story. And I bet some people in the audience might actually have questions about that. Before we open up the floor, I'm curious if maybe you can talk a little bit about how you see the value of MongoDB changing as it relates to the evolution of AI and agents, especially in the financial services industry, because we all know that it has a lot more requirements.
Yeah, so I think what I'm seeing, and again, I've been attending this conference for the last few years now, and I can see a trend, a kind of a paradigm shift happening with MongoDB itself. MongoDB is kind of started with a modern database, now kind of is evolving as an AI infrastructure. Like you have everything. Think about the developer tool that you talked about. Think about the AMP announcement that had happened earlier in the morning. And the whole Voyage thing was pretty impressive, and the way that you can do hybrid search, like with embedding vector search and the text search together in one platform, using one set of code, I think that's impressive. I was very fascinated by the fact about the announcement on the search facility available on on-prem enterprise version, because there are workloads running on-prem. Before they can move to Atlas, we can still take advantage of that. So I think I can see there is definitely a lot of core, like we can use MongoDB as our foundation for building some of our AI capabilities, and some of them we are already using it, but we are doing in a slightly complex way. But I think lesson learned from today's announcements, I think we're going to go and experiment for a few of them and try to simplify those pieces.
I think that is a really great summary of what we saw in the keynote, and I'm really excited to work with your team to see how we can take advantage of those tools with what you're doing.
Look forward to it.
We have about a minute and a half left, so I think that's enough time for maybe 1 or 2 questions. Should we open the floor and see if anybody has any questions about your experience and your use case on Atlas? Does that sound good? Okay, awesome. Does anybody have any questions? It's a little hard to see with the lights, but raise your hand high if you do, and we can bring a microphone to you. Okay, we have one up here. Awesome. There's a microphone coming so that it's a little bit easier for everyone to hear.
You mentioned that there is a MongoDB plugin for IntelliJ. Is it available for free for download, or like you purchase it? How like in our project we are transitioning to MongoDB, and we work with IntelliJ. And I would like to try that plugin.
Great. You should definitely go to plugins in IntelliJ, and if you search within the Marketplace tab, you'll be able to find it, and it's free, and you can install it and start using it today if you want.
It's called MongoDB plugin, or how is it called?
It's called MongoDB for IntelliJ, but it's under plugins, because that's what IntelliJ calls their extensions.
In the Marketplace in IntelliJ?
Yeah, within IntelliJ.
Okay, thank you.
Yeah, of course, no problem.
And we are using, our MongoDB is on-prem. We are using Compass, but Atlas is not available. Atlas is not available if you are on-prem, right? You need to be on the cloud.
Yes. So Atlas is the name of our it's the name of our database as a service platform in the cloud. So there are separate ways of running MongoDB, but Atlas is our service way of doing that. So it is in the cloud. Yes.
So you demonstrated some AI capabilities for Compass. How can do we need upgrade for Compass?
Yeah, so in our latest versions, I'm actually really excited to let everybody know about this. I know that we're at time now, so this is the last thing we're going to say, and then we have to wrap it up. But we actually have made a recent change to natural language querying in Compass. The feature has been around for about 2 years, but recently we removed the requirement for Atlas login within Compass to be able to use natural language querying. So customers like yourself who have on-prem deployments now have a really easy way to take advantage of natural language querying. So all you have to do is upgrade to the latest version. This was released, I think, about 2 weeks ago, and you can start using natural language querying. Great, thank you all so much for coming, and thank you to Bupendra, our special guest. Thank you so much.